Maybe you think you are the only one in this situation, but I received some emails from other students about this same matter. Attendance issue, it's not my business. For me, the students who attend with me courses before that, they know that I don't care about your attendance. But the attendance this semester is the decision of the university, not my decision. I'm just following the rules, okay? And you know me, I don't like to break the rule. If anyone have special situation, it's not my business. You can make the lecture for the department, for the rector office, for I don't know for whom, but not for me. Okay? I know you came only because I spoke with your friend. To solve the issue for the midterm. Okay. Anyway, let's continue. Today we have a new subject. Okay, it's the first algorithm we talk about clustering. Last algorithm, KNN, it was about classification, yes? This time we have K-means, it's about clustering. What's the difference between classification and the clustering? We mentioned it, yes, before. What's the difference? Okay, so classification, it's supervised learning, yes. So we have training set that have some labels. Then when we train our model using these labels, now the model know the specification of each class. Okay. So if we have a new element or object, we need to classify it in the groups that we already learned our system. So the system will check, or the algorithm will check the features. It's close to which class more. So if it's close, for example, to class X, then the new object will be classified to class X. Okay, what about the clustering? Okay, clustering, it's unsupervised learning. Means there's no teacher to teach the model or the algorithm. But we give the algorithm some information. For example, we give the algorithm what features we need. By the way, there is another algorithms that make feature selection, so you don't need to select even the features. It's not our business now. Okay, so we have to identify which feature, which properties for the items that will be used for clustering. What's the meaning of a clustering generally, as a word, not as a making groups? Yes. For example, I can make clustering for the students here as, for example, males and females, two groups. I can make clustering for the students as repeated students fail and repeated taking. And I can make any grouping, not only two groups, I can make 3 groups. For example, short, tall, and medium students, for example. Okay. This first issue, what features to a group depend on it. Second issue, how many clusters we have, how many groups, okay? So we can give some functionalities for the system, for the algorithm to identify number of groups. Okay, here, what's your name? Muaz. Okay, Muaz, turn off the lights. Thank you, Muaz. Muaz what? Muaz? Isili. Isili or Al-Isili? Isili. Where are you from? Sindh, but not Gaza. Haifa. But you say where? Your family? Jordan. Okay. Okay, so Muaz. K means it's a clustering algorithm. K, number of clusters. Okay. Means it's from the calculation. It's use the means. Means what's the means? What's the means of the means? What do we mean by this word? Means. Average, yes. The average. So the means average here, yes. So we cluster depend on the average system or the average distance, sorry. What do you mean by distance? We mentioned it in a classification, yes? Distance between what? And what do you mean by distance? How to calculate the distance? Okay. Distance of features, yes? If we have 2 features, then we have 2 dimensions. Yes? If we have 3 features, then we have 3 dimensions. 4 dimension, I don't know how to, because as humans, we can't imagine 3 dimensions maximum. But computer, you can use 4, 5, 10 dimensions. Okay? So each dimension is a feature, and each object, depend on this feature, will have here 3 dimensions. This means we have 3 values, x, y, z, for every point. Objects. So this object, this another object, another object. Each object considered as point, and we see the distance. Yes. Here's the idea of k-means. I tried to mention it generally, then we will speak about it. The idea about k-means, we will take something called centroids, or center, merkez, yes, center of what? Of the group, of the cluster. So if we have 2 clusters, how many centroids we have? 2. If we have 3 clusters, 3 centroid point. If we have 4 clusters, 4 centroid point. Centroid point means the center of what? Of the group, of the cluster. So, randomly, we take only 2 points. For example, if we have 2, then we try to find the distance between each point and center. So it's belong to this center. Then after we finish, we calculate the means of all the points in one cluster. That's why it's called K-mean. Two clusters, we will have two means. Means we calculate the average for X points and Y, and for example, Z, if we have three features, then we will have a new point. We start with specific centroid. After that, we will have a new center depend on the means of all the points. Then again, we repeat the process again. We find the distance of every point, not in this cluster, in all the cluster from the iteration and the new center. So maybe this point was in class A, but after calculate the distance again, it become with class B, and so on. We repeat this iteration until when we calculate the means for every group, then we will stop. So how many iterations we have? We repeat the calculation how many times? We don't know. It's depend on when we make the means calculation in the iteration and there is no change in the value from the previous iteration, then we stop. Okay, this is the general idea. So now we will speak about this issue. So clustering, we mentioned it again. It's about not classification here means classify or get the objects into different groups, okay, depend on some features for each object, okay. So the data set will be divided into some subset. How many subset depend on how many cluster we have. Okay, so each subset shared some common trait means features, okay, properties. We have two general categories for clustering algorithm. We have hierarchical algorithm. Okay, so we have two categories: hierarchical algorithm, partitional clustering. Okay, hierarchical algorithm, it's have two subcategory: agglomerative. Agglomerative, it's come from aggregation. You know what's the meaning of aggregation? Aggregation means gather some objects in a group, okay? This is the meaning. So this type of algorithm or bottom down, it's a start from the elements. So we consider each element as a different cluster. Then, okay, so we have 100 elements, then we have 100 cluster. Then we start to gather the elements or the clusters that are close together until we reach number of clusters that we identify. For example, we identify that we need 3 clusters, then we will stop when we reach 3 clusters. And that's why it's called bottom up. So we start with each object as cluster, then we start together the objects that close together in groups, clustering until we reach number of clusters. For example, if we have 2, then we will stop here. We have 1, 2 cluster, and so on. So that's why it's called bottom or bottom up. From each element as a cluster, then gather them if they are close together, until we reach number of cluster. Divisive, it's come from division, yes? So it's top down. We start from all the elements in one cluster. Then we divide it into subcluster. Then this subcluster, for example, divide it into another sub until we reach number of clusters that we identify or we need. For example, 3 clusters, then we will stop here. That's why it's called start from all the elements in one cluster. Okay. Most modern algorithm is partitional clustering. In partitional clustering algorithm, we make calculation and identify cluster. We don't start from each one in one cluster or all in one cluster. No, we make number of clusters that we need one time directly. But you mentioned that k-means it's iterative, yes? Okay, but for example, we have 3 clusters. We will organize all the elements into 3 clusters. Then we make calculation and we change the elements from one cluster to another cluster. So, yes, Hassan. Which one? This one? Yeah. And this one? Yeah. No, here we don't start with all the elements in one cluster. We divide the elements directly into partition, into number of clusters that we need. For example, if we have 5 clusters, then the start directly will be from 5 clusters. But here we start all the elements, all the set will be in one cluster. Then we start to divide it, okay? So we have examples like K means fuzzy, C means, okay, QT clustering algorithm. Most of the algorithms for clustering, for classification, depend on the distance, okay? And one of the calculation here will be the means in most of the algorithms, okay, of the clustering. We will take example as k-means. So we will focus here about k-means. There's many applications like marketing. Okay, I will, for example, classify the countries to as high sales, moderate sales, and low sales. So we focus on countries with that we have low sales amount for it with more advertisement, for example, or give some offers and so on. So marketing, land use to similar land will be grouped into specific group, insurance company to identify groups. As you can see, most of the examples is about grouping the objects into subgroups. Okay, let's speak more about k-means clustering. So it's unsupervised, iterative. What do you mean by iterative? Means repeat the steps until we reach the final result. So we repeat almost same steps calculation will be repeated. I hear some sound here. It's come from where? Okay, I done it. The battery is good, so it's not from the battery. Okay. So what do we mean by K? As I told you, number of cluster. Of course, K must be less than N, number of objects. But how many K we need? It's depend on. Sometimes we identify number of a cluster, depend on our business. Okay. But we have also some algorithms to identify number of a cluster or possible clusters. We will speak about one of them, but almost, for example, last year I brought a question in the midterm exam, but the other teacher said I did not give it to my students. So I will teach you that one, but I'm not sure if we will have a question in the exam. But K means we will have. How to calculate K here in K means I will give it to you, but it will be in the exam or not, I'm not sure yet. I did not decide, okay? Its work as clustering, so elements in the mention it. I hear the sound again. It's like something tried to connect. Hopefully it's not here. I think we don't have problem. What's this one? Windows update. Start. I don't want to restart now. Schedule. (12 a.m.) Is it today, 12 a.m.? Make it 10 p.m., for example. Okay. Make it Saturday. Okay. Okay, okay. So the idea of K means it's depend on the means of or the objects, features, or attribute. K is number of a clustering. Each cluster have a point, we called it centroid. Centroid is the center of gravity or the means. That's why it's called K means. Okay, so let's go to the algorithm directly. So first step, we select K. How many cluster we have? Okay. So we identify K. If we have, for example, 3K, then in the second step, we will select random. Doesn't matter where we will start. Random K points as a centroid points. So if we have some points here, okay, so we will select For example, we have two clusters. So K here means number of centroid, number of points. It's equal to the selected number of clusters. So if we have two clusters, for example, then I will select two random points. Random? Yes, random. It will be changed later. It could be points from the data set. Yes, it could be any two random points. Okay, so we will select two random points. Then we will assign each data point. What do we mean by each data point? Means each element in the data set. We will assign it to the closest centroid. So here we have 1, 2 centroid. Each point will be calculated, or we will calculate each point distant from first centroid and second centroid, for example, if we have two clusters. Third centroid if we have three clusters. So if it's close to centroid 1, then it will be with centroid 1. If it's so centroid 2, it will be with cluster 2. If it's close to centroid 3, then it's related to cluster 3. Okay. After we assign each point to the cluster or the centroid point, then we will calculate the variance or the means for each cluster. So now we already grouped, we clustered all the elements into number of groups. Then for each group, we will calculate what? The average, the means. Okay. This average or means, it's the new centroid. So the centroid, it's not a fixed point. It will be changed depend on the average of the cluster. So for this one, for example, after we calculate this centroid, maybe will move here. And this one maybe will move to this place. Then when we move the centroid, this means the points will be classified or grouped maybe in different groups this time. So if we change the centroid, then step 5, it means repeat the third step again, and we assign each point again to the new centroid. We keep repeating these steps until the centroid point or the means of each cluster did not change from the previous step. If it did not change, this means now we have fixed centroid, then we have fixed clusters, we have fixed group. Then we finish. So if the reassignment occurs, then we will repeat again. If not, go to finish. Okay, so usually we don't ask you to write the algorithm, we ask you to work on the algorithm, so to calculate. So we will give examples. This example, just a visual example. Okay, so in this visual example, we don't have calculation or numbers. In the next example, we will have the calculations. Okay, so consider in this example, we have this visual plot. Then we have these elements or objects. we don't know these objects belong to which group. Let's check the calculation before starting this one. Take what I said, calculation. Take the attendance, sorry. I focus after I mentioned the word. Okay, let's check the attendance. I will open the attendance for you. So, pattern recognition, attendance. Okay. So, the password is, or the code is 74334. Okay. Hopefully you will stay smiling until the final exam. Yes? Not working. Why it's not working? You tried another time? Hello. I know, but when I leave it, it's working. So I will close the attendance. Later, I will take the second attendance. Okay. So we have here two features. Okay. For example, M1 here, or X, and M2 or Y, two variables or features or property for the objects. Okay. Then we have these objects and we need to group it. So we will take random. First step in the algorithm, what? Identify how many classes you have. For example, we have 2 classes. Then, second step, I will set random k. K here we select as 2, so 2 points as centroid for each group. So we get this one, the blue one, and the orange one or yellow one. I see it as orange, but I think I wrote it as yellow here. Okay. So what's the next step? Calculate the distance for each point from every centroid. For example, here, let me just change the color. Yeah. The distance between this point and this centroid and this point and this centroid. The distance between this point and the centroid and so on. So at the end, I will group or cluster each point with the closest centroid. This is a fourth or third step. Okay, so at the end, it's like we have here a line, we called it median, yes? That's come from the middle distance between the 2 points. So you will see that all these points belong to the blue one, and all these points belong to yellow or orange group. So now we have these 2 groups. For each group, the blue group and the yellow group, this centroid, it's not fixed. We will calculate the mean for each group. So after calculating the mean, for example, the mean it's come here, it will be the new centroid. And the mean here, for example, here. For example, I'm not sure. Well, so we change the centroid. How we change the centroid? Calculating the means for each group. How to calculate the means of each group? For example, if we have points A, B, C, D in first group, and these points have, for example, 3 values. If we have 3 features, okay, x1, y1, z1, x2, y2, z2. Of course, this could be number or will be numbers, okay? x3, y3, z3, x4, y4, z4. Means the numbers for each point. How to calculate the new centroid or the means? The summation x1 plus x2 plus x3 plus x4. How many values we have? 4 divided by 4. So x1 plus x2 plus x3 plus x4 divided by 4. Then we have y1 plus y2 plus y3 plus y4 divided by 4. Same issue for z. z1 plus. Then this is a new centroid point. Okay, so this is the idea. Then here, as we can see, the center of a graphic or the centroid point will be changed for each group depend on the calculation of the means. So after it's changed, we calculate the distance. When we calculate the distance again, for example, we found that this point, it was more close to the yellow. Now it's more close to the blue. These 2 blue objects, it was more close to the blue, but now it's become more close to the centroid of the yellow. Then this one become yellow or orange. This one become a blue. So the groups now different, the clustering. What I will do again, calculate the average or the means again. Maybe one will be moved here or here, I don't know, depend on the average. And I will calculate the average again. If the average change means centroid will be changed, then I will calculate the distance for each point again and see the new group or cluster and so on. So I will keep repeating until the centroid will not change. If it's not changed, then we stop. That's why we said it's iterative. We repeat the step. Iterative means we repeat the steps until the centroid is fixed and not changed again. Then we will have the number of clusters. Okay. So it's for you in details. So we can have a break now. Okay. So 10 minutes break.